guys, it's Ben from Pragmatic Software Engineering, and today we're going to be talking about arrays and linear data structures. This episode is a precursor to actually getting into our data structures. Specifically, this video is required before you view lists. As of right now, the only way to have a concept of multiple things that we know in computer science is an array. But there are problems out there where you have a collection or a sequence of things that you are constantly adding to. And if you recall, arrays have fixed size. So if you create an array of 5, you can neither add nor remove elements in that array. Let's think about an example here. We're going to be building a new browser, and this browser we're building has a concept of history. So as you go to different websites, maybe Google, Microsoft, pragmaticsoftwareengineering.com, as you go to these new websites, you're adding a new element into this sequence. Well, you can't do that with an array. There's got to be a way where we can have a collection and add to it and still benefit from having loops and sets and adds and deletes. I want you to think in an example. This example is a mailman, and the mailman is going down a street. He has a bunch of addresses he needs to deliver to. The mailman is like your processor. He has to visit all these different houses, all these different addresses, which are memory addresses, and do something at that address. At the address in our example, the memory address, will have some data. A mailman is going to figure out how to create the best route from one side of the street to the next side of the street. So he'll likely go through and hit all the houses on both sides. This is a methodical and efficient way to do it. But imagine if the mailman was a little less methodical. So he goes, delivers from house 1, then goes to house 20, delivers, then goes to house 2, and he's ping-ponging around. It's going to take a lot more time. So arrays benefit from actually allocating a bunch of memory and having all the array elements be adjacent to each other in memory. This means the processor can go fairly quickly through an array. This also comes at a peril though. It means that when we've allocated an array, we cannot grow or shrink the array. It will forever be a static size. If we change this idea of making all the data in the array be adjacent, and we change it so that every piece of data has a next address attribute, we can then break out of this sort of linear block of data that's allocated, and we can start putting data in different parts of the system. This is slower because we have to go through and fetch all of that data, but what it does is it allows us to grow even more. You could say infinitely, but obviously you can grow until your resources go right. In our next video, we'll be talking about lists, which is a contract, an interface, and some of the implementations that you can find in Java. Although we're going to talk about Java implementations, the things we'll be talking about are still fundamentals and can be extrapolated to different languages. So, as an example, we'll be talking about array lists and linked lists. I hope you enjoyed this video. Please like and subscribe, and check out our website, our new website, pragmaticsoftwareengineering.com. On our website, you can find some articles I've been writing for engineer growth. Thank you very much, and have a good one.